In this video we'll be calculating the acceleration of gravity at the surface of the moon. So consider an object of mass m at the surface of the moon. This mass is acted by an acceleration of gravity on the moon, gm. Thus the force exerted on the object by the moon is pointing downwards towards the moon's center, and it has a magnitude mgm. Here I draw for you the moon, big M, and the object, little m. The dimensions of this object, little m, are small with respect to the moon's radius that we can consider the object to be a point mass. The goal in this video is to find gm. To do so, we need to isolate little g on its own. To do this, we need to first make the assumption that the moon of mass big M is a perfect sphere with all its mass uniformly distributed in volume. Under these assumptions, the moon can be considered to be a point mass located at its center, and we could use the universal law of gravity to calculate the magnitude of the force exerted on the object by the moon. Here, little r here is the composite distance from both the object and the moon's distance from the center of the moon. But we can approximate little r to just be the moon's radius. Our initial assumption is that little m, the object, is relatively small. So thus, little r is equals to big R, which is just the radius of the moon. If we go back to our equations, we can sub in our little r with big R, and also cross out little m on both sides, as I'm going to do here. As you see, little m cancels, and our big R is right here, and that's subbed for the little r. And what we get is that the acceleration is equals to the gravitational constant multiplied by the mass of the moon over the radius of the moon squared. Of course, we could solve for this for a numerical value, given the constant values here, the mass of the moon being in kilograms, the radius of the moon being in kilometers, which I converted back into meters, and of course the gravitational constants, which is always constant at this number. And if we plug that in, of gravity on the moon is just 1.6 meters squared. This value is actually 1/6 of the Earth's gravity, 9.8 meters per second squared. And that's our answer.